Hello everybody, once again it's me, James Wash, and I'm here today to make a fun little video about math and a joke I heard earlier. So let's get started. The joke goes like this. 3 logicians walk into a bar. I just draw them right here, it doesn't have to be super duper special. And the bartender says, "Do all 3 of you want a drink?" And the first one says, "I don't know." The second logician says, "I don't know." And then the third logician says, "Yes." That's the end of the joke. And if you think about it for just a moment, it probably still won't make any more sense to you than it did initially. And that's the way it was for me too when I heard the joke first. But when I thought about it a little bit more, I realized that there's something here that's very funny. It's something that's, well, maybe not funny, but it's interesting and entertaining. It's very much like a logic puzzle, just as much as it is a joke, and I want to explain why. First off, these 3 guys, they are logicians. What's a logician? Well, a logician is a mathematician who specializes in the field of logic. Logic, which is just figuring out when things are true and false, and how can we know that things are true and false, and the study of the qualities of true and false and how they can be determined, is all logic. And logic is a field of mathematics. So every time you do something like a Sudoku puzzle, or you solve like a logic puzzle, like you might see in a puzzle book, like one of those ones where it's a grid of like different people at different times or different items. One of these grid puzzles, you are doing logic. You are doing mathematics. You might not think about it that way, but you are. Some would argue logic is one of the most important aspects of mathematics. So, a logician is a mathematician who focuses on studying logic. Well, how does that make the joke funny? Well, in logic, there are things we call statements. And basically, a statement is any sentence that we can say is true or false. So, like, the sky is, oh, that was horrible, blue is a true statement because we can show that the sky is blue. Or something else like, my name is James, that's a true statement. Those are both sentences that we can say is true or false. Alternatively, something like, a trout can fly is a statement, but it's a false statement because trout cannot fly. It is a sentence that can be said as true, that can be said to be true or false. In this case, it's false. And then, if you said something like, pink is the best color, or, fridges should only be purple. Well, no, that's not a good example. If you were to say, like, pink is the best color, or tile is the best kind of floor, those wouldn't be statements. Why? Because they are not provably true. They are matters of opinion. Generally, a statement of opinion is not a statement. And if something can be demonstrated to be absolutely true, then it is not an opinion. A statement, again, is the sense that can be said to be true or false, provably, demonstrably so. And that is at the core of the joke setup. Remember, at first, the bartender says, do all three of you want a drink? That's a question, but we can rewrite it as a statement. We can turn do all three of you want a drink into say yes, or wait a second. Wait a minute. Okay. The bartender begins the joke by saying, "Do all three of you want a drink?" Well, can we think of this question as a statement? Not really, not in the way we would think of it, because it's asking a question. Questions by themselves are not statements because they are not stating things. Now, all three of you want a drink. That is a statement because it can either be true in that all three of them want a drink, or it can be false, in which case at least one of them would not want a drink. And that's important for the joke. Okay, so what is this saying? So basically we can use this sentence, we can use this question as a command. Say yes if all three of you want a drink. This is a logical command. It's an if-then. If all three of them want a drink, then the logician should say yes. If one or more of them doesn't want a drink, then they should say no. That's called the contrapositive. If you have a statement that says, like, if P, then Q, an equivalent statement is if not Q, then not P. Those are basically saying the same thing. Say yes if all three of you want a drink. If one or more of you don't want a drink, that's the reverse of Q. Then say no. That's the reverse of P. So, the bartender, basically, by the question, gives the logicians a logical instruction. Say yes if all three of you want to drink. So let's go back to the three logicians. 1, 2, 3. Okay. Now, the bartender asks, do all three of you want to drink? Or, say yes if all three of you want to drink. Or, equivalently, if one or more of you don't want to drink, say no. So what does the first logician say? I don't know. And that might seem weird at first, but it actually makes a lot of sense. First off, think what would happen if the first logician said no. What does that mean? Well, if the logician said no, then that means that one or more of the logicians doesn't want to drink, right? Well, neither of these two have said anything, so this logician wouldn't know if any of them want to drink. So if he says no, that means he doesn't want to drink, and because all you need is one or more to not want to drink to say no, that's what he does. But he doesn't say no, does he? He says, I don't know. Okay, so we would know that he would say no if he didn't want to drink, and he would say yes if all three of them wanted to drink. Why does he say, I don't know? Well, there's a reason. Remember, if he didn't want to drink, he would say no. But just because he wants a drink doesn't mean he'll say yes. The question states to only say yes if all three of them want a drink. Again, these two logicians haven't said anything. So, instead of saying so, this logician can't say yes because he doesn't know if they want drinks. So if he says, I don't know, instead of no, that means that he does want a drink, but he doesn't know if either of these two wants a drink as well. So he says, I don't know. So we know that this logician would very much like a fine drink. The second one says, I don't know. And the logic here is basically the same. If this logician didn't want a drink, they would say no, because that's what they're supposed to do. If one or more of them didn't want a drink, say no. He is one of the logicians. But if he doesn't say no, that means he does want a drink. But this logician still hasn't said anything. So he can't say for sure if all three of the logicians want a drink. He can't speak for everybody. So he says, I don't know. We can conclude that he too would very much like a beer in his hand, but he can't speak for the third one. Finally, the third says yes. In lots of these puzzles, it's assumed that logicians, like the people acting, can immediately work through the other logical processes of the other people that are present with them. So this logician, seeing these two guys say I don't know ahead of time, knows that they both want drinks, because if they didn't want a drink, one of them would have said no. So he knows they both want drinks, and he knows that he wants a drink too. So all three of the logicians want a nice cold drink. So finally, the third logician says yes. And that's the joke. It's very much like similar logic puzzles I've heard about, like people wearing hats and trying to guess the color of their own hat, or similar things, and they all work off similar principles. Each person is trying to work through the problem, the logical constraints of the problem, and every time someone responds, the next person gets a little bit more information. The third logician knew the first two logicians wanted drinks, because otherwise they would have said no. Every time they said something, he knew a little bit more. And that's the way that logic works sometimes in actual mathematics. You start off with a basic statement, and then you move forward through different pieces of information, like people's responses, to figure out what you can conclude. And I just think that's pretty entertaining, and a pretty fun way of demonstrating a field of mathematics. I really like this joke. Thank you for watching. Have a lovely day.